All right, I'm the solution to everybody's problem in this room. And that's what we are dreaming about, is how can we get you to Heathrow Airport in 15 minutes from here, door to door. And that's what we are trying to achieve at Lilium. And probably beyond Heathrow Airport, maybe one day also those that are lucky enough to live in Paris. Lilium, we believe, of course, transportation and mobility is an incredibly large market. Of course, the next thing is the on-demand. Mobility is a proven concept, and the next stage there will be the autonomous vehicles. But we also believe that there is a very clear case that there's a third element, that is air mobility and on-demand air mobility. And that could have quite a significant chunk of that very large $3 trillion market opportunity. So what you need in order to do that is, of course, a jet. And then we are building the world's first electric VTOL jet. So VTOL stands for vertical takeoff and landing. And why is world first is like because it has 36 jet engines in it, and that is a different concept to probably some of the things that you have seen in the past. Okay. We also think it's going to be an on-demand opportunity. So in order to do that, we want to make sure that everybody in this room in the future will be able, on their smartphone, to set a pickup location, set a destination, and have an end-to-end experience, how to get there fast, and how to get there with a pretty reasonably high range of 300 kilometers as well. So where are the economics? Why hasn't it been done before with helicopters? Two key reasons with helicopters. One, they are loud. So 20 decibel difference is actually about 4 times as loud as what you can do with an electric propulsion jet. Secondly, they're actually pretty expensive. So you're looking factor 6 on the cost per kilometer. We believe it's possible to do it at about $1 in cost per kilometer. And that is in a world where we're not yet talking about fully autonomous flight, where we're not talking about what is actually really going to be possible in the future. But already then it becomes comparable to what you can do in a car. But the trick is it's a lot faster than a car. So in a place like London, and the difference is a bit like if you live in Munich, it's probably slightly less, but in a place like London, we're talking about like a 15 times extension of what we call your life radius. And having lived like many years here in London, I think the red circle on there is pretty generous. I actually don't think you can do that in 15 minutes, really. But it's a completely new rethink in as much as what can you do in the course of a day? How can we actually look at living in the countryside, working in a city, even like the cross-city connections. So you can talk about a St. Albans to Gatwick high-speed connection at 300 kilometers an hour. So lots of different opportunities that are coming up. And why is it happening now? What you need in order to get close to people, you need to actually have a low noise solution. You need to be able to take off and land vertically, so you don't need runways, you don't need a lot of space to get to places. But you also need to solve the steering skill problem, we call it, i.e. pilots. So the machine that we're building is already from day one highly autonomous. It's the machine that stops the pilot from doing something wrong. It's the machine that already has a flight envelope that is pretty autonomous, and over time will be probably fully autonomous once the regulation is catching up. And with that, of course, we're coming to the technology. So what's the goals here? It's got to be we want to make it as cheap as a high-speed rail network. It has to be comparable. It has to be potential for mass market, certainly for everybody here in the room. Quiet as a fan. 300 kilometers an hour, which is pretty fast, especially if you go in lower altitudes. The range, 300 kilometers. CO2 neutrality, of course. In the urban spaces, it's important that we don't add pollution. We don't add more CO2 in there. Obviously, conscious that you're also having always a dependency on the country that originates the electricity, of course. And safe and simple. So the game change, and you see that on here, what changes everything for us is what we call transition. So we're not only going up vertically and holding ourselves up vertically in the air with just the downward pressure from the engines, but we're then actually transition into forward flight. So the way the engines are currently in the position, that would be your starting position, and as you go up, you go into forward flight. And that's when the physics change. That's when you actually start getting aerodynamic lift from the wings, and that's how you start talking about pretty high ranges and the ability to fly fast and the ability to get to places. But it's also the simplicity. So the whole concept is designed to be simple. So there's a lot of repetitive parts. The engines, of course, are all the same. There's no tail rudder, there is no water cooling, there's like a whole number of things that you'd have complications in a helicopter and in more classic concepts. But it's all really reliant on the jet engines, and it's reliant on that symmetric setup of the jet. The engines, it's what makes it also pretty special. They're called ducted jet engines, which means that it's only a single part that is rotating. It means they are encased, so if you have a bird incident or something like that, you don't have blade loss and things spraying other people at high velocity. But it also allows you to look at noise profiles and vibrations in a very different way, and to play with sound suppression and ultra low noise concepts. And of course, safety. So we are believing, and then our ambition is to have the jet fully certified as a commercial aircraft. That means everybody who's flown here, you're not thinking about safety when you're actually getting on a plane. It's the safest method of transportation. And we want to stay exactly in that same range. So everything is ultra redundant. Every single piece can fail, and there's a secondary computer or battery electric power system. And of course, we are also saving the plane from the pilot himself. So the plane, as I said at the beginning, isn't going to let the pilot make mistakes. So, and last but not least, you have the ultra redundancy of a parachute in case you're coming down. So where's all of this going? And when you look at it, that means we have a completely rethink of what infrastructure we are going to be needing in the future. So talking of high-speed rail, talking of large-scale infrastructure products, you can completely rethink. All you need is some concrete slabs and pads across the country, and you start creating a web of 300 kilometers an hour connections. You start talking, you can connect a country or a kind of California or a place probably at like $20 a kilometer of high speed rather than $40–50 million per kilometer of high speed connection. And that means probably for many of us, the dream of probably living in the countryside, working in the city, becoming potential realities, it means we start thinking about our buildings in the future in a different way, rethinking like how do you actually access things from the top. We believe that communities will be open just for the sake of the benefit that these technologies are going to bring, to be open to let these jets come very, very close to urban areas. And so our creators, I do believe we are at the dawn of an entirely new industry. Because it means, so here's an illustration of what that would look like in Berlin. You have in the middle your landing pad, around you have your parking spots. All of that is going to become possible, and it's going to be an opportunity to then engage in that. So lastly, we raised a lot of money. We're hiring a lot of people. We're looking for chief people officer. We're looking for top talent, global top talent to make this a reality. And with that, thank you very much, and I think we probably have a few more questions from Marco in a second. Thank you.
Thank you so much.